Let's remind ourselves of the general form of our exponential equation. It's y is equal to a b raised to the x power. So let's go ahead and look at our first example, and it says y is equal to 2 raised to the x power. I don't see anything in this a position, so that means that my a value must be a 1, the implied one. My b value is 2. So let's go ahead and break down some more properties of this function and then graph it. And we will graph using either calculator or Desmos. And so you may want to make yourself a note that in order to use our graphing calculator, you go to the y equals button, you put in 2 raised to the x power, and then second and graph. That's going to get you to the table of values so that you can grab some values to plot this. I'm going to go ahead and go to Desmos and grab the points from there. Here we are in Desmos, and this is what our function or our equation y equals 2 raised to the x power looks like. In order to be able to easily graph this, I'm going to go ahead and go to the little gear button and click on a table. And this is going to give me some values that I can use. I think I want to go ahead and grab a couple of more points. So I'm going to go ahead and say 3 and 4 and maybe -3 and -4. So notice how quickly at these negative x values that our y values are getting closer and closer to 0. However, we're going to talk about the fact that they never cross 0. It looks like it's almost there on the line, but if you really super zoom in, you will see that it never crosses 0. And so 0, or the value of y equals 0, is going to be an asymptote, just like we learned about with our rational functions. So let's go ahead and go back to our notes and graph these points. All right, so you should use the points that you found in your table to plot your graph, and this is what the graph will look like. Let's go ahead and identify some things on the graph. The first thing I want to identify is the y-intercept, and I can see that that's at the point 0, 1. And one thing that I want you to notice and recognize is that that point at 1, that is our a value. So this point is 0, a. The next thing is our asymptote, and we talked about that when we looked at the graph. The graph never crosses 0, and so our asymptote is at y equals 0. Domain. We have a graph that very sharply heads towards the left. It slightly heads to the right as it goes very steeply up, but it is going to keep going to the right and up as far as we can imagine. And so our domain is going to be all real numbers. And now our range, we know that we have no graph below 0. And in fact, we don't have graph at 0 either. So y, our range, is going to be greater than 0. Not greater than or equal to, because this graph never actually touches 0. It's going to get super close because of that asymptote. It approaches 0 but never quite gets there. Put yourself a note over here to the side to remind you of what an asymptote means. One last thing that I want to point out before we move on to our next example is that our b value occurs right here. So at a x value of 1, this is our b value of 2.